Good day! So for this experiment, we will be exhibiting a titration wherein we would want to determine the citric acid content of this juice right here, which is Smart C lemon, by titrating it with sodium hydroxide. So what we will do first is a direct clamp into an iron stand, graduated cylinder, delivery flask, a volumetric flask containing 0.125 molar sodium hydroxide solution. This 0.125 molar sodium hydroxide solution was created by dissolving 0.5 grams of sodium hydroxide and diluting it into a 100 milliliter vessel, which is this volumetric flask here. Also have my pipette. Okay. So, without further ado, let's begin. Okay, so what we will do now is we will pour our sodium hydroxide solution, 0.125 molars, to our burette. We must ensure that our burette is closed. It's closed, so with our makeshift funnel, we will pour in our sodium hydroxide and see up to where it will go. Okay, I think that's enough. Stopper this. As you can see, the sodium hydroxide measures at around sodium hydroxide measures at around 0.7 milliliters. Okay, so I will record that down. What we will do now is we will put 10 milliliters of our juice, our fruit juice, into this iron layer flask. So, this is now my 10 ml of Smart C lemon, and I will now place this in my iron layer flask. Okay, so before we can proceed with the titration proper, I will just place around 3 to 4 drops of phenolphthalein indicator. Okay, so that's 3 drops of phenolphthalein indicator. Now we can proceed with the titration. Okay, so now that our solution with phenolphthalein is now ready for titration, I will now open the stopcock and will let it be open until I see something go. Okay, so after running the titration for some time, it has reached this color pink. If you are not sure, if you can see the pink in the background when I put the Erlenmeyer flask against my white lab coat. So this is a perfect light pink. Initially I thought it was dark, but I just needed to wait it to settle. I did not do anything more, and it reached a light pink. Now we will read the final amount of the volume of sodium hydroxide left here in this. And I got that initially, and I'm just going to read it again. And initially it's at 9 it's at 9.4. It's at 9.4, but due to due to some problem in the design of the burette, it kind of leaks. Good thing that I already read it earlier, because right now it's down to the 10 ml mark because of the looseness of the burette. But nevertheless, the final volume that I recorded earlier is at 9.4 milliliters. The thing is that it just went down, so I'm going to write here 9.4. And from the initial and final volumes of sodium hydroxide left in my burette, I would be able to calculate the amount of of citric acid present in this Smart C. I will do that by connecting the amount of sodium hydroxide that I titrated with the molarity, which is 0.125 molars, and multiply the volume of sodium hydroxide used with its molarity to obtain the number of moles of sodium hydroxide, and then connect that to the stoichiometry. Since citric acid is triprotic, so it needs at least three sodium hydroxide molecules to attain this. Like, it needs 3 sodium hydroxide molecules. So that translates to a 1/3 ratio, and from that I will obtain my number of moles of citric acid present in this Smart C lemon, and then I will divide that with my initial amount of Smart C, which is 10 ml. So I would obtain the concentration in terms of molarity of citric acid in this Smart C bottle, Smart C lemon bottle. So that is it for this experiment. Thank you and have a nice day.